Alright, I am back in my original location, and we're going to finish up 9.3 today. Guys, 2 more chapters after this. 2 more! Woo! Alright. We'll all be graduated, living life to the fullest. Alright. Jeremy, if you're listening to this, well done, sir. Alright, so here's the deal. A level of dissolved oxygen in a stream or river is an important indicator of the water's ability to support aquatic life. A researcher measures the DO level at 15 randomly chosen locations along a stream. Here are the results in milligrams per liter. Can we conclude that this aquatic life in the stream is at risk? Carry out a test with a 5% significance level to help you answer this question. What? They don't give me any data. I mean, they give me this stuff, but where's my mean, where's my standard deviation? Alright, that's today. You guys know how to find mean and standard deviation from a bunch of raw numbers. It's called a calculator, right? Okay, so, I know we should do state, plan, do, conclude here. I am going to go state, and I'm going to skip a few things just because I do have to do the abridged version. I'm going to write my hypothesis. You should write more than just a hypothesis, but I'm going to say HO. Well, my mean should be where? Alright, it says a dissolved oxygen level below 5 puts aquatic life at risk. So I'm going to assume it's at 5. Now, we have to check my alternate hypothesis. I want to check to see if it is less than 5. Does that make sense? Alright, so here's my normal curve. Oh boy, here they come. Here they come. Alright, so I should be at 5. I'm going to see if it's less than 5. If it's less than 5.
Hey Dad, I kissed your wife.
You kissed my wife?
Yeah.
You pot licker. Okay. Alright. Okay, so here we go. There's state, plan. I'm going to skip over the plan too as well. Can you wave? Alright, let's get down to the do. Hey, don't stick your tongue out at them.
Hey!
Get out of here. Come on. Dad's working. Man, it's not easy to put these things out like this. It takes a lot of hard work. I gotta focus. I'm gone now. Okay, alright. Here's my do. Alright. Well, first of all, I don't know what I got. These are my 15 samples. Alright, so here's what I'm gonna do. I'm gonna blow it up nice and big. And I'm gonna go to stat. Okay? Now remember, edit is where I put all raw data. And I'm just gonna
Good night,
go.
Dad. Come up.
Good night, bud. I love you, alright? Okay, I'll come up and give you a kiss when I'm done. Okay, so here's all my raw data. Now I put it all in here already. Right? I don't know if you can see that. Okay? And if you scroll all the way down, you know there's all my data. Okay, so there's the 15 things. I put in data. Now, why don't you take some time, put that in, pause the video if you need to. Alright, now, once you've written it all in, I'm going to hit stat again, and I'm going to go over to calculate, and that's only one variable that I've entered in. It's in my L1. I'm going to hit enter. I do not want a frequency, so do not put anything in the frequency. I want everything to just read as it is in L1. That's for more probability-wise things, and I'm going to calculate. There we go. Alright, so I got a mean. Let's change it back. I got a mean value of 4.77. So I got something down here. 4.77. Alright, now, I want to know the probability of getting that result or less. Okay, so 4.77 is what I got. Is it dangerous or was this just a fluke accident? Are all the fish gonna die? Okay, well, I don't know if the fish are gonna die. So we're going to see if this is just a fluke accident and it's actually around 5 or if, you know, we got to empty the stream. All right, so do what I got, 4.77 minus what I should have gotten at 5 divided by the standard deviation. Now remember, I only have a sample, and if you look, you actually want the one that's the S, not the sigma, and the one that's labeled S actually has a standard deviation of 0.93. Let's go 9.5 just for kicks and giggles. Usually you only have to go 2. Divided by the square root of 15. Alright, that is my t-score, right? It is a t-score because I just have a sample here. I'm going off these 15. Alright, I'm going to plug this into my calculator again, and I'll give you guys the results. Remember, it's going to go stat, tests, t-tests, and I'll be right back. You want to select t-test, okay? Alright, so I got my p-value. My z-score was a negative 0.94, so I'm almost 1 deviation below the average. And I have, basically, I figured out my p-value is 18. So I had an 18% chance to get the result I did if 5 is the actual average of water, alright? That's pretty good odds, guys. Like, it's very possible I got this fluke accident, right? I had 18% chance of getting that if 5 was true. So in conclusion, I'm going to say, alright, conclude, alright, I'm going to say, colon again. Okay, I will fail, let's make that bigger, fail to reject the null. Meaning I don't have enough information to say it is actually lower, because 18% chance of getting this low result is possible. I'm going to fail to reject the null, meaning what are we going to do to these fish here? Can we conclude that aquatic life in the stream is at risk? Okay, meaning we don't have enough info to say aquatic life is at risk. Right? If it was below 5%, I would have rejected the null, but the p-value is high, so the null will fly. Alright, next, B. Given your conclusion in part A, which kind of mistake, a type 1 or a type 2 error, could you have made, and explain what this mistake could mean. Alright, so here's the deal. So remember, a type 1 means you reject, just like my sister-in-law. Asked once, she rejects. Okay? We didn't reject. Right? Type 2 is we accept, or in our words, fail to reject. So we did a type 2, because that's what we did. We failed to reject. And what does this mean? If we did make a type 2 error, so we failed to reject, but it's actually, we should have rejected it. So what this means is, we said the fish were fine and dandy, comma, but one day down the road, all fish are dead. Okay, right? We messed up. Stinky place now. Alright, that's bad. Okay. Alright. Cool. Next, last question. We got 6 minutes. We can do this. Okay. The Hawaii Pineapple Company, and I've been there. I've been to Hawaii Pineapple Company. Thank you, Guam. I traveled through Hawaii. Managers are interested in the size of pineapples grown in the company's fields. Of course, we're interested in the size. Last year, the mean weight of pineapples harvested from this large field was 31. So that was last year. Okay, overall. A new irrigation system was installed in the field after the growing season. Managers wondered whether this change will affect the mean weight and future of pineapples. So we want to see, does this irrigation system work? Then, all right. To find out, they select the weight of a random 50. All right, so we have a sample size of 50. N is 50. N is 50. All right. Uh-oh. I hear thundering. Buddy, just a second, guys. I'll be right back. Alright guys, I got 5 minutes till I have to rock my son to sleep, so I gotta do this. Okay, the Minitab output below summarizes the data. So here we go. Out of 50 people, oh notice, Minitab, here's the size of our sample. Oh, here's the mean. Okay, there's this SE mean, and then there's the standard deviation. Okay, wow, I wonder what that all means, okay? Well, let's check this out. Do a sig test. Alright, so you're going to do a state. Okay, you're going to do a plan, do, conclude, right? We're going to kind of skip over that. Once again, I'm going to do my hypothesis just because we need extra practice. My hypothesis would be, hey, the pineapples stay the same size, which is what, 31 ounces? Nothing changed from last year to this year. This time, though, I want to see, does the irrigation, what? The irrigation system was installed in the field. Managers wonder whether this change will affect the mean weight of future pineapples to grow in the field. We're just wondering if it will affect. So that means it could be higher increase or lower increase. So I'm going to say the mean is not equal to 31. I don't care if it's higher or lower. I just want to know if this irrigation changes it. Okay? So that I would state, plan, do. All right, so let's get to the do part. All right, I don't know. Might have to do fast photography here. This is also going to be a t-score because I got standard deviation from those 50. Okay, so what I got was 31.935. Notice Exhibit A. That's my mean from my 50. Minus what I should have gotten, which was 31. All right, now that's not very far off. I was only maybe 1. And then I'm going to take the standard deviation, which is 2.394. and divide it by the square root of 50. Now, all right, just give me 1 second. I got to calculate something. All right, so when I calculated this t-score, I got a t-score of 2.76. So we actually got quite a far away. So I know it didn't seem like it, but we should have hit around 31, according to my math. And I actually hit 31.935. All right, now here's the deal. I'm double whamming this, so I want to go this way over, and I want to get this way. Remember, it's two-sided test because it's not equal to. I came up with a p-value of 0.008. That p-value is very low, and is it lower than this 5% significance level? That's where I'm drawing the line. Yes, the p-value is low, so the null must go. I'm going to reject. Alright, reject the null. Alright, now, before we go, and I would write that a little bit more in context, but that's the math, basically. Okay, so I'm going to reject the null, because the p-value is low, the null must go. Now, here's the funny part, because you see I underlined this, right? And you might say, well, what does the SE mean? What does that mean? Guys, actually, it's kind of cool, because what does standard error mean? It's actually the 2.394 divided by the square root of 50. So they've already calculated that for me. That's my standard error. So that's this part down here. So I could have, instead of putting this down here, I could have literally just put in 0.339. Same thing. Okay? That's kind of cool. Now, we're going to finish off. It says, now make a confidence interval for the true population for a sample with a 95% confidence interval. So my sample, so I'm pretty sure it's at 31 point, or my best guess of the pineapple size right now is right here. I'm going to plus or minus this. I want to be 95% accurate. However, my degrees of freedom is going to be at 49. All right? Right? Okay. So I'm going to have to see exactly where that is. I don't know if I have even a z-score chart, but I'll be right back. Okay, so here's my chart. 49 is my degrees of freedom, so I got to go down to my lowest one, which would be 2.021. 2.201. Okay. And so that is going to be my confidence interval, 2.201. That's going to be my critical value. And then, you know, I'm still going to put that 2.394 in there divided by square root of 50. Alright, so I would do that, get my final answer, be done. Guys, happy chapter 9. Good luck. Peace.